What's up everybody, I'm Jason and welcome back to the channel. So this week, instead of doing a video talking about some specific function in the R5C, I've decided to talk about something a bit more general with respect to cinematography, but certainly relevant to the R5C and relevant to some of the discussions that I have had with people in comments on videos on the R5C. And that topic that I'm going to talk about today is shutter angles. So we are going to be looking at shutter angles. And I'm going to try to do this as comprehensively and in-depth as I can across the board, from sort of why we even have them, to what they're good for, to how to deal with them, and the math involved with that. Now, the way I think that is best way to go about doing this is to first start by talking a little bit about shutter speeds. This is what most people, I think, certainly if you're coming to camera like the R5C from Canon's mirrorless cameras or DSLRs or pretty much any other mirrorless camera, consumer level mirrorless camera on the market, with the exception really of those from Panasonic. Panasonic has always included shutter angles as a feature on their mirrorless cameras for at least as long as I can remember. But anything from Nikon, Sony, etc., there's going to be, you're not going to have shutter angles, you're going to all have shutter speeds. So that's what you're probably going to be used to. So to start this off, I want to start by asking a rhetorical question, but sort of going back and just kind of thinking through things for a second, because, you know, it's easy when you are really familiar with something to kind of stop thinking about what fundamentally it is that the thing that you're handling is doing, or thing that you're using is doing. So what exactly is the shutter speed, or is a shutter speed? Well, there's a couple of ways to approach this. You can approach this from the purely technical side, in the photographic technical side of things, where it's an exposure handle. So coupled with the aperture and the ISO, the shutter speed is the thing that is setting how bright your image is going to be, how well exposed it is. From a creative perspective, the shutter speed, you could say, controls motion blur. Changing the shutter speed fast or slow is going to control how much motion blur you ultimately have in your picture. And while the exposure and motion blur are interrelated, depending on how you're looking at all of the settings as a whole, your exposure triangle and what you're trying to accomplish, one of those aspects may be more important to you than another aspect there. But ultimately, from a sort of very fundamental perspective, when we're talking about shutter speeds, what we're really talking about is something that directly represents and controls how long light is exposed to the frame or sensor. So how long that the exposure actually is. It's a direct control over something in the camera, similar to how aperture settings directly control how where the aperture mechanism is set to, or the film sensitivity is directly what the sensitivity of the film is. There are no interleaving sides to this. It's just a shutter speed. If you set it to a 50th of a second, then light will be exposed to the sensor or film for a 50th of a second. So that's what a shutter speed is. Now, to really start to talk about shutter angles, we have to stop and look at shutters as a system and a mechanism in a camera, as a thing that does something in the camera, and specifically controls how much light is reaching the sensor. And so I wanted to start with a shutter that we're probably, or hopefully you're very familiar with, the simple focal plane still photographic shutter. It's what's basically in every mirrorless camera that's out there. Two curtains, they open, they close, the shutter, or that gives your exposure time. You know, if you ever take the lens off your camera and look at what's covering your sensor, assuming your camera closes the shutter when you take the lens off, this is what you're looking at. And of course, with anything that's engineered or designed, it's always the entire process of engineering it is always about optimizing and designing it for the task at hand. And a focal plane shutter is very much a still photographic shutter, and it's very much designed with those premises in mind. So for starters, they're designed to be flexible. Flexibility here means a couple of things. It means that they can have easy control of a wide range of exposure times. So you don't need to make complicated changes in the way that the camera controls things. And ultimately, when we're talking about, say, still photography, every frame that you shoot can have a different shutter speed than the frame before it. It may bounce between two, it may go all over the place, but it doesn't really matter. Every frame can easily have a different shutter speed. Additionally, the shutter mechanism needs to be designed to have a wide range of available shutter speeds. So everything from the ability to shoot hours-long star trail images at night to shoot very fast shutter speeds so that you can freeze action in an F1 race or air races or a peregrine falcon in a stoop or something like that. So those are sort of the broad kind of design requirements, but there's also a couple of other requirements that we have in a still photographic type shutter or one of these focal plane shutters. One of those is that it has to be small. It has to fit in a camera, and nobody's going to carry around a mirrorless camera or a DSLR that's like this big. It has to be something that's very compact and efficient in that respect. And it also has to be very performant. Lightweight is a big factor in this. The lighter something is, the less motor and power and force you need to accelerate it. And if you want to have very fast shutter speeds, you need to be able to accelerate one of these shutters very quickly so that it can move across the film's surface, or the sensor's surface, the frame's surface, very quickly. All of this ultimately leads to some significant drawbacks with respect to complexity. So if you look at any focal plane shutter in a camera, they're complex. If you go back and you look, looked in the service manual, the newest service manual I had for a camera, it happened to be for Canon's T90, so this was a camera out of the mid-1980s. There's more than 60 parts, including the drive assemblies, which are essentially assemblies at the service level. They're made up of subcomponents in the manufacturing process. There's essentially 60 parts, or more than 60 parts, in the focal plane shutter in that camera. That's a lot of parts. And when you combine the fact that there's a lot of parts with the fact that the parts are designed to be as light as possible, to be as fast as possible, as compact as possible, you run into a lot of durability issues. Not necessarily bad durability issues, but the durability is limited, at least within the context of what we're ultimately talking about here, which is a motion picture situation or cinematography. And of course, we can see this durability situation when we look at actual published shutter life expectancies for cameras. So my first DSLR was a Canon Rebel XTI, and it had a published life expectancy of shutter life expectancy of around 50,000 cycles. My current cameras, the EOS R5s, have an order of magnitude better shutter life expectancy. It's around 50 or 500,000 cycles. Both of these actually are pretty good for a still camera. If you are thinking the XTI could only shoot 3 or 4 frames a second in continuous drive, so 50,000 frames is going to take you a while to shoot. But again, I said this is problematic in the context of a motion picture camera. If you're shooting at the standard cinematic frame rate for a motion picture of 24 frames per second, then, what that means ultimately is that in 1 second, the camera has to expose 24 frames. And since the shutter has to fire once per frame, that's 24 cycles on your shutter. In 10 seconds, it's 240 cycles, and in 100 seconds, it's 2,400 cycles. Now, 100 seconds is not really that long. It's 1 minute and 40 seconds. It's not even 2 minutes we're talking about here. In 1,000 seconds, which is just 16 minutes and 40 seconds of continuous shooting, you've shot 24,000 cycles in a cinematic context. That works out to be about half of the life expectancy of that shutter in the Rebel XTI and about a 20th of the life expectancy of the shutter in the EOS R5, assuming that they actually were you were actually using those shutters in a cinematic context. So the camera engineers building motion picture cameras from the very start realized that this wasn't a viable solution. They needed something simpler, and they needed something that was better adapted to the environment and the situations that they were shooting in. And quite honestly, the situation is somewhat different. So where in still photography, we needed the ability to easily change the shutter speed on a frame-to-frame basis. In a motion picture camera, we need a shutter that can repeatedly get the exact same exposure on a frame-to-frame basis. In fact, we don't need to change the shutter speed all that often or that much at all. You certainly aren't changing it on a frame-to-frame basis. You almost certainly are not changing it on a take-to-take basis. In fact, you're probably not changing it on a scene-to-scene basis or at all in the scope of shooting all of the footage for your film. Most exposure adjustments in cinematography, or in fact, almost all folks' exposure adjustments in cinematography are taken up using a different film speed, a different aperture, and neutral density in front of the camera to bring down the brightness that is actually reaching the shutter, because the shutter speed is by and large fixed to get a consistent look across the entire film. We also have a much more limited exposure range that the camera has to work with. A motion picture camera doesn't need to be able to shoot a 2-hour or 3-hour long exposure and then shoot a 32nd or a 15th of a second or a 8,000th of a second. In fact, if you think about it, the reality is that if you're moving film through the camera at 24 frames a second, you can't have an exposure that's longer than a 24th of a second, or the exposure is bleeding into when the next frame's supposed to be there. And in fact, if you think about it in a film camera, because you have to advance film, you can't even have an exposure as long as a 24th of a second. It has to be somewhat shorter than that still, because the camera needs time to actually advance the frame. Going the other way, towards faster shutter speeds, there isn't as much of an open, in-depth, or ultimately long duration or fast shutter speed needed there either. With still cameras, we can always use a faster shutter speed. We're seeing it now with modern digital cameras that can hit a 32,000th or a 64,000th of a second in exposure times. But in a motion picture context, especially if you're shooting at low frame rates like 24 frames per second, you need motion blur. There just isn't enough frames per second for the human eye to take over and apply, create the motion blur on its own. The camera has to, or the film has to have the motion blur baked in to continue that smooth appearance of motion, or as smooth of appearance of motion as is possible at 24 frames per second. So going up to really high shutter speeds is also not especially necessary. It's doable, but not especially necessary. Of course, the big one here is durability. 100 or a million or 100,000 exposures or hundreds of thousands of exposures really just doesn't cut it. You need to have millions of exposures. You're not going to have, or it's not going to be very viable to have a motion picture camera that the shutter fails after, say, even 1 million exposures and a couple of hours of shooting frame time on it as a whole. So the cinema camera engineers came up with a different solution. Different set of problems warrants a different solution, and ultimately that different solution gives us a different way of talking about what's going on. So the solution they came up with is a rotary shutter. There's rotary disc shutters, there's rotary reflex shutters. They all are fundamentally the same thing. It's a disc on a stick. You spin the disc, cut part of the disc away, spin the disc, and that is your shutter. Where the disc is missing, light can pass through to reach the film. Where the disc is opaque or there, light can't reach the film, and so the shutter is essentially closed. As with all shutters, this is synchronized with the frame rate or the frame advance. So there's one shutter revolution or one revolution of this rotary shutter per frame. It has great longevity benefits, well, ignoring the fact that it's really simple. There isn't all of this mechanical stuff going on. It's down to a few parts, potentially as few as like 2 or 3 parts, but probably less than 20 in something that actually allows you to change the shutter setting or the shutter angle without having to take something out of the camera and replace it. But it's also really reliable because there's no stopping or starting or reversing. There's no hard impacts on a per frame basis. You have rotation in a bearing, and as long as the bearing is lubricated properly, that rotation is basically going to produce 0 wear and tear on the camera. So it's easy to get millions and millions of shutter actuations or shutter cycles with this kind of process. But this also completely changes how the shutter can be talked about. With a still camera shutter, and the reason I started there is it's very clear we can talk about shutter speeds because you have, for example, two curtains and one curtain opens and then sometime later a curtain closes. It's pretty, regardless of what the exact mechanism is in a still camera shutter, whether it's a focal plane shutter or a leaf shutter or simply taking the lens cap off the lens and putting it back on, there's very clearly a defined start and stop. But now we're talking about a shutter that's just rotating. And yeah, it's rotating in sync with the film, but it's just rotating, and part of it is removed. So simply talking about a time doesn't necessarily make sense, especially considering that you can change the frame rate that the camera's shooting at. So your 30th of a second disc shutter, like, it doesn't even translate well. In fact, saying that just makes no sense because, well, 30th of a second at what frame rate, at what rotational speed is that 30th of a second, a 30th of a second? Because it should be pretty obvious that if you spin the disc faster, the time it takes to open and close is going to be different. So what they did, instead of trying to use numbers for, times, is they simply looked at how much of the disc is removed, measured the central angle of that, and said, well, this is the shutter angle. If you take a quarter of the disc away, the central angle of that is 90 degrees, and that's a 90-degree shutter angle. It's how long the shutter is open out of the 360 degrees that it takes to rotate in a complete circle. It's an implied fraction, the shutter angle divided by 360 degrees. It's not 360 degrees because, it's 360 degrees simply because that's how many degrees there are in a circle. So here's an example. I wanted to get an actual rotary disc shutter, and then I thought better of it. My background's computer engineering, and I'm perfectly comfortable taking software apart and putting it back together. Not so comfortable with the idea that I wouldn't take a camera apart and destroy it in the process, and that just seemed a combination of expensive and disrespectful to people who actually might want to shoot with that camera in the future. So you'll have to settle for a 3D animation instead. So here's an example, as I said, of 3 different rotary shutters, disc shutters in this case. On the very left, we have a 90-degree shutter angle. A quarter of the pie is removed. In the middle, we have a 180-degree shutter angle. Half of the pie is removed. And on the right, we have a 270-degree shutter angle. 3/4 of the pie is removed. All of these are spinning at the same rates. The film in this case is advancing at the same frame rate, you could say. But you could see very clearly here that depending on how much disc is there, changes how much time each individual frame is being exposed in the 3 different examples. So the 90-degree shutter angle is closed more than the 180-degree shutter angle is, more than the 270-degree shutter angle is, but they're all rotating at the same time. So, as I said, shutter angles are a multiplier. It relates, ultimately the mechanical process, or ultimately they're a thing that describes in the mechanical process the fact that you have something that's rotating in concert with the frame rate that is in turn producing an exposure time and not directly an exposure time itself. We can also see this in a practical sense. So if we change the frame rate, but we keep the shutter angle constant, we can see the exposure changes. Now, I just showed in the animation, if we change the shutter angle, but keep the frame rate constant, the exposure changes. That should be pretty obvious because more or less of that disc is being exposed. But here's the example of the counterpart. So we're looking at, obviously this was shot on a digital camera, but if you notice up in the top, the frame rate is being changed from 24 to 30 to 60 to 120 frames per second. The aperture, the ISO, and the shutter angle at the bottom of the screen are all staying the same. They're not being changed. And as I change the shutter speed, as I change the frame rates, the exposure changes. And the only thing that can be a product of changing the exposure, if the aperture, the ISO, and the light levels, which I'm not messing with the light levels here, change, is that the shutter speed changes, except the shutter angle here is, of course, 180 degrees. It doesn't change. So there's that relationship. The exposure is changing because the shutter angle is causing it to change when you change the frame rate. Okay, so obviously I've been talking for a while now about film cameras. And the reason I've been talking about film cameras is that that's where this technology originates. People don't like change. That should be hopefully pretty obvious to most of us. When something works and works well in your field and you're used to using it and dealing with it, then people will not particularly be interested in changing that just because something else changes. In this case, the underlying technology is changing. We're going from film to digital electronics, and as a result, the ways the actual underlying hardware is working changes. But if you're a cinematographer and you've worked your entire life with shutter angles, what's the advantage of changing from, say, shutter angles to shutter speeds, even though that's kind of more in line with what a digital sensor actually needs to work properly? And actually, there's an even better point to be made here, which is that there's a really good reason to work in shutter angles, which I will talk about in a lot of detail at the end of this video in a couple minutes. But there's a very good reason to do it and not necessarily work in shutter speeds. And it has to do with consistency of motion blur. So the camera companies aren't stupid, as much as they sometimes seem to be that way to many of us because they don't implement some feature we want. They aren't completely, they're not going to come out and they're not going to say something like, well, everybody's used shutter angles for all these years, but we're not going to do that anymore because they're stupid and they're not how the sensor works. And this is doubly so when we talk about anything that's computer-driven. Computers can do math. Yeah, there doesn't need to be a rotary shutter in your digital camera or digital cinema camera, but we can explain how that shutter works in a mathematical equation and how the translation between that rotating disc shutter and what angle it is converts to time. And we can do that math in a camera to convert what we show in the user interface as shutter angles into the exact timing that the camera sensor needs to deal with the image. And so that's what the cameras do. They simply use their computational capability, of which they have more than adequate capability to do, to convert the frame rate you've set to the camera to and the shutter angle that you've set the camera to into the exact timing information that's needed to control the sensor. So what are these conversions? Obviously, if the camera can do math, and I'm saying it's simple, then we can look at the math and potentially do it ourselves. So the first one to look at is converting from a shutter angle to a shutter speed. This is what your camera's doing all the time when you're shooting in shutter angle mode. It needs a speed or an exposure time, and you're telling it to shoot at a certain shutter angle. So the equation for this is this. The exposure time is equal to the frame time times the shutter angle divided by 360 degrees. Now, if you're not familiar with what the frame time is, it's simply 1 over the frame rate. So if you're shooting at 24 frames per second, each frame has to be in the camera for no longer than a 24th of a second. Pretty straightforward. Unfortunately, as straightforward as this equation is, the math and numbers that it kicks out are kind of gnarly. You end up with a situation where you're looking at something like 0.02 seconds. What the heck is 0.02 seconds? I certainly don't have a 0.02 second setting on my camera. Well, actually I do, but it's not expressed that way. So on our cameras, fractional shutter speeds are expressed as fractions. That 0.02 seconds is actually a 50th of a second. But, who wants to do that kind of math in their head or on their calculator or whatever to figure out that translation? So we can rearrange this formula here a little bit. We kind of flip things over to figure out what the denominator is in that shutter speed fraction. So the denominator of the shutter speed, there's an implied 1 over here, is equal to the frame rate times 360 degrees divided by the shutter angle. So what does this work out to be? Let's just do an example here. You're shooting at 24 frames per second. You have a 180 degree shutter angle. What is the shutter speed or exposure time going to be? Well, 1 over 24 times 180 divided by 360. That simplifies to 1 over 24 times a half, which is a 48th of a second. If you're using the simplified calculator, smartphone-friendly calculator equation, 24 frames per second times 360 divided by 180 equals 24 times 2 equals 48. But remember, there's that implied 1, so it's 1 over 48 or a 48th of a second. Obviously, we're not shooting 48-second long exposures when we're shooting at 24 frames per second. Now, as an aside, if you've ever read an entry-level or beginner-level article on video, shooting video and getting cinematic look in your video, and they always tell you to shoot with twice the frame rate, this is where that comes from. Historically, the shutter angle used for cinematic content is 180 degrees, and that basically multiplies your frame rate by 2. So if you're shooting at 24 frames a second, it would be a 48th of a second. If you're shooting at 30 frames a second, it'd be a 60th of a second, and so on. But this is where that comes from. Now, going the other way, converting from a shutter speed or an exposure time to a shutter angle. When would you want to do this, or when is this necessary? Well, this comes up when you're dealing with flicker. So if you're shooting 24 frame per second content, say an interview for a documentary or something, but you're shooting it in a country with 50 hertz electricity, like anywhere in Europe, basically, or most of Africa, then you're going to need to pick a shutter speed that allows for the flicker to be removed, essentially. Will work in a whole cycle of the rate relative to the AC frequency. So you would want to shoot at a 50th of a second instead of some arbitrary shutter angle like 180 degrees. So to do the calculation here, we're going to just do this. The angle is equal to the exposure time divided by the frame time times 360 degrees. Of course, this brings us back to that problem of gnarly numbers. The exposure time is going to be a decimal. The frame time is going to be a decimal. That's hard to do on a smartphone calculator. We just don't want to deal with it. So we can flip things around and basically do what we did in the first time and make this more friendly for a smartphone to calculate. We can say that the shutter angle is equal to the frame rate divided by the denominator of the shutter speed times 360 degrees. So here's an example. If we're shooting at 24 frames per second and we need a 50th of a second for our exposure, then we're going to do 24 divided by 50 times 360 equals 172.8 degrees. If we're shooting instead at 30 frames per second, we still need a 50th of a second for our exposure time. We're going to do 30 divided by 50 times 360 equals 216 degrees. Which brings me to a reiteration of a point that I hope is already pretty obvious. Shutter speed or shutter angles are frame rate dependent, or the exposure that you get from a shutter angle, I should say, is frame rate dependent. So this brings me to a comment that I wanted to address that I had received in a previous video where the commenter was seemingly pretty frustrated or angry that Canon didn't include 172.8 degree shutter angle at presumably all frame rates. And I'm not quite sure, so the simple answer to this is Canon does include a 172.8 degree shutter angle where it's relevant. But I'm not quite sure what the or where the misunderstanding is, or I think where the misunderstanding is again, going back to this idea that shutter angles are going to be the same shutter speed at every frame rate. That's not really the case, or that's simply not the case as we've shown. So on a Canon camera, you'll see something that looks like this. I've omitted some superscripts that just aren't relevant. But it will say when you're looking at the shutter capabilities of the camera for the angle setting, it'll give you a list of shutter angles from 360 degrees to 11.25 degrees. And then it also says, and also the angle equivalents to the following shutter speeds, and then gives you a list of fractional shutter speeds from 1/120th of a second to 1/25th of a second. What the camera's doing here, these are not equivalent, or not necessarily equivalent. So 120th of a second is not a 360 degree shutter angle unless you're shooting at 120 frames per second, and then it actually would be a 360 degree shutter angle. But it's not a 360 degree shutter angle at some other value, say a 60th of a second. It's only a 180 degree shutter angle at a 60th of a second. So what Canon's actually doing here, instead of just giving you the ability to enter an arbitrary shutter speed or shutter angle, is that they're calculating these fractional shutter speeds, they're calculating the angle that they would correspond to, and then they're putting that in the list of shutter angles that you have. So if you're shooting again at, and this is the reason I used the example that I just used, if you're shooting at 24 frames per second in angle mode and you scroll through, you will find that there is a 172.8 degree shutter angle there. But if you change the shutter or the frame rate to say 30 frames a second, then it'll be 216 degrees and you won't have a 172.8 degree angle because it doesn't have any value in that configuration. And this also applies to all of the other or the odd shutter speed or frame rates that you would have if you're shooting in fast and or slow and fast motion. So if you're shooting at 22 or 28 or 36 or 48, the equivalent of 1/50th of a second is going to be a different angle in all of those speeds, and the camera is going to do that for you and show you the correct angle in that speed that corresponds to a 50th of a second. So the other thing is I've had some instances where people just don't seem to believe that the math is what the cameras are doing. But we can actually verify this. If you're interested in doing this for yourself, the best way that I've found to verify the math is to set up a scene and use the camera's exposure meter. So the exposure meter doesn't care about shutter angles. It cares about exposure time, it cares about the aperture, and it cares about the ISO. So we can set up a scene with the camera in one mode, say angle, center up the meter in that mode, and then switch to shutter speeds and find the shutter speed that matches. And see if that matches what we're predicting with the math. So here's an example where we're working at 120 frames per second, and we've got the camera set to 180 degree shutter angle. And I've centered up the meter, and I've switched the camera over to shutter speed instead of shutter angle. And as you can see, if I have the shutter speed set to a 2/50th of a second, the meter is centered up again. Now, we predicted a 2/40th, we are showing a 2/50th. Clearly, those are not the same exact numbers, but if you do the math to figure out what the error between the two is, it's 6/100ths of a stop, which is not going to show up on the meter on the camera, and it's not going to be meaningful in any way with respect to actually producing content. For this one, I picked two completely arbitrary numbers that I had no preconception would be used anywhere in anybody's video, so it's not like you could just look this up. I would just know this. I'd have to do the math. So we're doing 48 frames per second, and we're looking at a 60-degree shutter angle. Now, the math predicts that this should result in a 1/288th of a second exposure time. So again, the meter's centered up. We're switching the speed or from angle to speed, and we're starting here at a 90th of a second, and we're dialing in, and lo and behold, at a 300th of a second, our meter is perfectly centered up again. Now, again, a 300th of a second and a 2/88th of a second are not the same number. However, and this is completely coincidental, the error here, again, is 6/100ths of a stop. So you're not going to see it in the meter, and it doesn't have any meaningful difference or relevance in actually talking about the image or the exposure that you're seeing. So with that said, I want to wrap this up with a when and how to use shutter speeds and shutter angles. As I said, shutter angles have an actual useful consideration. And the useful consideration for a shutter angle is in how you should think about it and how they translate when you're shooting video. So the way I shoot or think about shutter angles is I think of them as motion blur priority. I know that's kind of an odd way to think about it, but if you shoot with a fixed shutter angle and you retime all of your footage that's shot either undercranked or overcranked, you will get the correct motion blur for what you're shooting at. So for example, to maybe make this a little bit more clear, if I'm shooting a movie and I'm shooting it for targeting a normal frame rate or a timeline frame rate of 24 frames per second, and I want my actors to actually look like super badass martial artists, you know, whether they are or not, but certainly beyond what would be normal human capability, then I can shoot with the camera undercranked. So instead of shooting at 24 frames per second, I will shoot at 22 frames per second. And when this is played back at 24 frames per second, it will make everything seem as though it's faster. Everything's going to be sped up a little bit. If I shoot everything with 180-degree shutter angle, the motion blur will look correct for the speed things are moving. And here's a demonstration of this. So this is a model train running around a circle of track on my desk as a demonstration. One of these videos, the one on the left, is shot at 24 frames per second, is being played back at 24 frames per second. The video on the right was shot at 120 frames per second, is being played back at 24 frames per second. Now you might look at these two videos and immediately go, yes, but the train's going the same speed. Well, that's because in the 120 frame per second video, I sped the train up 5 times, or by a factor of 5. So it's going 5 times faster than it was in the other video. But the important thing to notice here is that the motion blur is identical. And remember, motion blur is not necessarily, or at least how much motion blur you need, is not necessarily a product of how fast something's actually moving. It's a product of how fast it's moving across the frame at the frame rate that you're playing it back. Now, if I'd have shot this same 120 frame per second clip with the train going at the same speed, slowed down by a factor of 5, it would be moving 5 times slower. And at that 5 times slower motion, the motion blur should be 5 times smaller, which would be the case if I had done that. On the other hand, if we're shooting with shutter speeds, think of these as exposure time priority. Whenever you set a shutter speed, that is the speed that the camera is going to be shooting the film at. If you set the camera to 2/40th of a second, it doesn't matter if you're at 18 frames a second or 12 frames a second or 120 frames a second, it's always going to be a 2/40th of a second exposure time. So where would you use this? Well, this of course would be when you need an actual specific exposure time for the content that you're shooting, that dealing with flicker situation. Now here's the final tip before I sign off on this video. Most modern cameras that most modern cinema cameras that support shutter angles also support shutter speeds. Save yourself the hassle, let the camera do the math. In situations where you need an exact exposure time, unless there's some other mitigating circumstance, do what I do, flip the camera from angle to speed, and then let the camera do that math for you and make the conversions for you. If you need to match motion blur across a whole range of footage, go to angle, shoot with a consistent shutter angle regardless of the frame rate that you're shooting at. So with that said, this pretty much shutter angles from stem to stern, why we have them, what they're good for, how they work, and how to convert back and forth with exposure times. If you found this useful or at least interesting, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. And as always, thanks for watching, and I'll see you next time.